Now we're going to look at quadratic equations. There's 4 different ways to solve quadratics, so let's go ahead and start with the first way. The first way to solve a quadratic equation is by factoring. So the most important thing to note when you are factoring is that first you need to be in standard form. In standard form means that you need your terms all on one side of an equal sign and 0 on the other side of the equal sign. So you have all your terms on one side and 0 on the other side. Once you're in standard form, then you factor. Well, how do you factor? Well, those are just hopefully reviewed for you. You do greatest common factor. If you have 2 terms, you do and see if you have the difference of squares. You factor your trinomial, or if you have 4 terms, you do grouping. So again, all that's going to depend on what's given. And then once you factor, you're going to set each one of those factors equal to 0 and solve for the variable. So let's look at number 1. Example 1 has 2x squared minus 5x minus 12 equals 0. So are we in standard form? Yes, we have all our terms on one side and 0 on the other side of the equal sign. So what we need to do now is factor. Well, this has 3 terms. Does it have a GCF, or a greatest common factor? No. So it's a trinomial, and I need to factor it as a trinomial. I use the guess and check method, and you can use any method that you're accustomed to. You can use that. So the only things that multiply to 2x squared are x and 2x, and then I just need to find things that multiply to 12 that I can put here that then are going to subtract up to negative 5x. So let's go ahead and try minus 4 and plus 3. I'm just going to check and see if this works. So 2x squared plus 3x minus 8x gives me my negative 5x I need, minus 12. Great, so I'm factored. Step 1 is done, step 2 is done. Step 3 says to go ahead and set each one of these factors equal to 0 and solve them both for x. So in our first one, we got x minus 4 equals 0, so x is equal to 4. And in our second one, we have 2x plus 3 equals 0. Move the 3 over and then divide by 2, and you end up with x is equal to negative 3 halves. So the solution step for this problem is negative 3 halves and 4. Let's look at example 2. Again, you ask yourself, are you in standard form? So I take a look at here. Do I have all terms on one side, 0 on the other side of the equation? I do. Great. So then I need a factor. Well, remember, with factoring, you're going to do things like GCF, difference of squares, trinomials, so on and so forth. So let's look between 6x squared and 54. Do I have a greatest common factor? I do. Both of these terms have a 6 in common. So let's go ahead and factor out the 6. If I factor out the 6, I'm left with x squared, and 54 divided by 6 leaves me with 9 equals 0. So now I have 6 times x squared minus 9 equals 0. Well, can I continue to factor this? I can. This has 2 terms, which is the difference of squares, and that's going to factor as x minus 3 and x plus 3. Alright, I'm all done factoring, so I need to set each one of these things equal to 0 and solve them all for x. So I have 6 is equal to 0, and x minus 3 is equal to 0, and x plus 3 is equal to 0. Let's take a look at the first one. 6 is equal to 0. Does 6 equal 0? No, it doesn't. So because it's just a constant, you discard it, because it is a false statement. It doesn't work. Then over here, I solve, I get x is equal to 3, and over here, if I solve, I get x is equal to negative 3. So I have 2 answers here, negative 3 and 3. Let's look at example 3. Well, example 3 says, same thing, solve this quadratic. Well, am I in standard form? No, I'm not. I have terms on both sides of my equal sign. So what I need to do is I need to move everything over to the left. So I'm going to subtract that 2x and add 5. Right? When I do that, I get 9x squared. Negative 4x minus 2x is a negative 6x. And negative 4 plus 5 is a positive 1 equals, these cancel, 0. Am I now in standard form? I am, because I have all the terms on one side of the equal sign and 0 on the other side. Well, great. Now I need a factor. Well, how does this factor? Well, it has 3 terms. Does it have a GCF? No, there's no GCF between 9, 6, and 1. So again, I factor by guess and check. So let's see, we need things that multiply to a 9x squared. Well, our options are really 3x times 3x or x times 9x. I'm going to try 3x times 3x. And then things that multiply to 1, our only options are 1 and 1. They need to add up to a negative. So let's make both of those negative and see what happens there. If I were to distribute this, I'd have 9x squared minus 3x minus 3x. Well, negative 3x plus a negative 3x gives me my negative 6x I needed. And negative 1 times 1 is a positive 1. I factored it correctly. So now I'm going to set each factor equal to 0, and I'm going to solve for x. Well, notice here, isn't that the exact same linear statement? It is. So I really don't need to solve both of them, because if I do for both of them, I'm going to get that x is equal to 1/3. So no matter which one I solved, I got x is equal to 1/3. So our answer is 1/3. And I wouldn't write 1/3 twice, because 1/3 is the same as 1/3. So first type of way that we could use to solve a quadratic was factoring. And again, hopefully that's a review. You have to do things like greatest common factor, difference of squares, trinomials. Sometimes you're given 4 terms and you'll be doing grouping. The second way that we're going to look at is the extractions of roots method. Well, in order to solve by extraction of roots, you really can only have one x in your equation. So if you look here, and I just want to show it to you real quick, notice that every single one of these only had one x, right? If you have something, and I'll just scroll up, like any of these problems where there was multiple x's, so there's 2 x's here, you can't use extraction of roots. So extraction of roots is very picky in the types of problems that you can use. So what does the extraction of roots method say to do? Well, the first thing I need to do is isolate the expression that you are squaring. Well, that's really important. You have to make sure that you isolate, and we'll look through that. Then after you do that, you're going to take the square root of both sides of the equation, and you're going to be sure to write a plus or minus with the side that had the number. And then we're going to just solve the resulting equations. So let's take a look at some of these problems. So I have 7x squared is equal to 4. Well, what am I raising to the second power? Well, the only thing that I'm raising to the second power, or the only thing I'm squaring, is x. So I need to isolate that. Is it all by itself on one side of the equal sign? No. Currently, I'm multiplying it by 7. So what I need to do is divide both sides by 7 to get it all alone. So I end up with x squared is equal to 4 over 7. Back to the same question. Am I isolated? Is that all alone, the thing I'm squaring, which is x, all alone on one side of the equal sign? It is. Great. So now I can do step 2. Well, step 2 tells me again to take the square root of both sides. So I'm going to take the square root of the left, and I'm going to take the square root of the right. When I take the square root of x squared, the square root and the square kind of cancel out, and I'm left with x. And then, again, you need to write a plus or minus symbol with the number side. So I need to write plus or minus, and then I can distribute the radical to both numerator and denominator. So that's really the square root of 4 over the square root of 7. Let's clean this up because you really don't want to leave a radical in your denominator. So first off, can I simplify either the square root of 4 or the square root of 7? I can. The square root of 4 is 2, so I currently have 2 square roots of 7. But again, I need to rationalize the denominator. I don't want a radical in the denominator. In order to do that, I multiply top and bottom by root 7, and I end up with x is equal to plus or minus 2 times the square root of 7 is 2 root 7, and the square root of 7 times the square root of 7 is 7. So your solution set here is, and you can write it as plus or minus, 2 root 7 over 7. Let's look at the next one. Again, step 1. Am I isolated? Well, I don't know. Let's check. What am I squaring? Well, I'm squaring the expression 5x plus 3. And I know that I'm squaring that expression because that's inside parentheses. Is this thing all alone on one side of the equal sign? Sure is. So I go to the second step. The second step says take the square root of both sides. So I'm going to take the square root of the left and the square root of the right. So the square root of 5x plus 3 squared is just going to be my 5x plus 3, because squared and squared cancel, equals, again, make sure you write that plus or minus, because this is a side with a number, and I'm going to need the square root of negative 4. Well, the square root of negative 4 is 2i, because the negative under the radical comes out as an I. Again, just in case you haven't seen it before or forgotten, please remember that the square root of negative 1 is equal to I, and that I squared is equal to negative 1. Right? You want to have this committed into memory. The square root of negative 1 is equal to I, and I squared is equal to negative 1. And this part won't come into play until a little later, but you do really want to make sure that you have this committed to memory. So took the square root of both sides, and I got that 5x plus 3 is equal to plus or minus 2i. So now I need to solve for x. Well, I have two different equations here. My first one is 5x plus 3 is equal to a positive 2i. And the second one is 5x plus 3 is equal to a negative 2i. So I need to solve both of them. I didn't need to split this up, and I'm going to show you kind of both ways, because we're going to look at things where we do actually need to split up. Here are my two equations. So if I subtract 3 from both sides, I end up with 5x is equal to negative 3 plus 2i. I can't combine negative 3 and 2i because they're not alike. This is an imaginary number, and this is a real number. Still solving for x, I'm dividing out my 5, and x is equal to negative 3 plus 2i all over 5. Great. Well, what about the other one? Well, if I solve this, same thing as subtract 3 from both sides, and I get 5x is equal to negative 3 minus 2i. Divide both sides by 5 to solve for x, and x is equal to negative 3 minus 2i all over 5. All right, well, notice that these really only differ by the plus and minus in front of the 2i. Because, and this may seem silly, but because this is what I call not a pretty number, and it's not a pretty number because it includes an imaginary number, so it's not really a real number that you can work with. So things that are not pretty, and I'll write that on the side, are things with i's in them or imaginaries, and then things with a radical that you can't simplify. So those are the things I'm calling not pretty. So since that's not a pretty number, I could have just done this whole thing one step at a time. And then if I show it to you down here, I would have subtracted 3 from both sides just like I did before. I get 5x is equal to negative 3 plus or minus 2i. And then I divide both sides by 5 just like I did before, and I get x is equal to negative 3 plus or minus 2i all over 5. Notice that here is the two answers that I got by splitting up. When you're not equal to a pretty number, there's no reason for you to split when you're solving for your variable. So the solution set, or my answers for this, are going to be negative 3 plus or minus 2i all over 5. Next one, example 6. 2 times 2x plus 1 squared plus 3 equals 11. First question I ask myself, am I isolated? Nope, I'm sure not. I'm squaring 2x plus 1, but I'm currently adding 3 to it and multiplying it by 2. So I need to isolate it first. Let's subtract off the 3 to isolate it. I get 2 times 2x plus 1 quantity squared is equal to 8. Am I isolated? Again, this is what I'm squaring. No, I'm not isolated. I need to divide 2 out. So I divide out my 2, and I end up with 2x plus 1 quantity squared is equal to 4. Am I now isolated on one side? Yes, I'm isolated. So what I need to do now is take the square root of both sides to solve. Let's take the square root of both sides. I take the square root of the left. I take the square root of the right. Well, the square root of 2x plus 1 squared, again, square root and square cancel, and you're left with 2x plus 1 equals, this is the side with the number, so I need to write plus or minus, and then the square root of 4 is 2. Well, again, am I pretty? Is 2 a pretty number? Yep, it sure is. Why is it pretty? Because it doesn't have an I, it's not imaginary, and it doesn't have a radical. That means that I must, in order to solve this equation, I must, right? I have no option, I must split this into 2. Again, my two equations are going to be 2x plus 1 equals a positive 2, and the other one's going to be 2x plus 1 equals negative 2. And now I need to solve both of these. Well, here I get 2x is equal to 1, and then x is equal to a half. On the right, I get 2x is equal to negative 3, and then x is equal to negative 3 halves. So my solution set here is negative 3 halves and 1 half. Again, when you're a pretty number, right? Pretty numbers again means that things that don't have i's and don't have radicals, you have to split into 2 like we did originally here. You cannot work it as a single problem. Right, so thus far we've talked about factoring and we talked about extraction of roots. Let's look at the last two ways to solve quadratics. The third way is completing the square. Now completing the square, remember when we did extraction of roots, I said you can only do it if you have 1x. Completing the square allows us to handle having more than 1x. So let's look at the steps for completing the square. First thing I need to do is get myself into standard form. After I'm in standard form, I take a look at a. A is again the coefficient of x squared. If it's not 1, I have to divide through by a. After I do that, then I need to move c, or my constant, to the other side. And then I'm going to put these plus blanks there. What's going to go in this blank is this 1/2 b squared. Right? Once I do that, I'm going to factor the left-hand side, and it's going to end up factoring as a squared binomial, and add the right, and then we're going to solve it using extraction of roots. All right, so let's take a look at doing this. Okay, step 1, get into standard form. Am I in standard form? I sure am. All my terms on one side equal on the other side. Step 2, if a is not 1, well, what is a? A is 2. Is that 1? Nope. Then I need to divide everything in the equation by a. So I'm going to divide this by a, and that by a, and that by a, and that by a. Remember, a in this problem is 2. So 2 over 2 gives me x squared plus 14 over 2 is 7x plus 4 over 2 is 2 equals 0 over 2 is 0. So I end up with x squared plus 7x plus 2 is equal to 0. Step 2, you got to move your constant c to the other side. So I'm going to rewrite this as x squared plus 7x plus blank is equal to, moving this to the right-hand side is negative 2 plus blank. Now I need to add something to both sides of the equation. And the number that we're going to add to both sides of the equation is going to be half of my b term squared. Well, which one of these is my b? Well, my b is 7. So half of 7 squared, well, that's really 7 over 2 squared, which is 49 over 4. So I'm going to add 49 fourths to both sides. I need to factor the left and add the right. Well, the left-hand side is always going to factor as your variable, and it's always a binomial squared, right? So it's going to be whatever variable you have. In this case, it's x. And then remember this number here, the number when I multiplied 7 by a half, and I got 7 halves before I squared it. So this half of b, this number right here, it's always going to be the same sign you have in the middle and then that number, and in my case 7 halves. So x squared plus 7x plus 49 over 4 factors as x plus 7 halves squared. It always factors as the variable, same sign as is in front of your bx term, and then whatever half that term was. In this case it's 7 halves. Now I need to add the right hand side, and again you can use a calculator if you want with this. In order to get a common denominator, let's see, I'd need 4, so this is really negative 8 over 4 plus 49 fourths, which ends up being 41 over 4. All right, well now I'm all done there. Step 6, which is where we are, is to solve by extraction of roots. When we know how to do that, I'm all isolated on this side of the equal sign, so I have to take the square root of both sides. So taking the square root of both sides, I get that x plus 7 over 2 is equal to, plus or minus, again, I'm going to distribute the square to both numerator and denominator, and I'm kind of do it over here because I'm running out of room. So it's the square root of 41 over the square root of 4, which is the square root of 41 all over 2, because the square root of 4 is 2. Is this a pretty number? It sure isn't. Right, so what do I need to do? I need to solve for x, and I can just do that in one step. So subtracting 7 halves from both sides, I get that x is equal to negative 7 over 2 plus or minus the square root of 41 over 2. So your solution set here is negative 7 over 2 plus or minus root 41 all over 2. Next one, same thing, solve it by completing the square. Step 1, get into standard form. I am in standard form. All terms equal to 0. Step 2, if the coefficient of x squared, if a is not 1, well, what's the coefficient of x squared? Well, there's no number there, so that's an implied 1, so I don't need to do step 2. Step 3, move your constant to the other side and add your plus blanks. So I have x squared minus 6x plus blank, and if I'm moving this constant term over here to the other side, it would be a negative 7 plus blank. Then I need to figure out what goes in the plus blanks. What goes in the plus blanks is 1/2 of b squared. Well, b in my case is negative 6, so I have 1/2 of negative 6 squared. Well, half of negative 6 is negative 3, and if I take negative 3 and squared it, I get a positive 9. So I'm adding 9 to both sides. All right, we'll factor the left. Remember, the left will always factor as something squared, a binomial that's squared, and it's going to be whatever your variable is. Happens to be that my variable is x, and then you're going to look here, and you have that minus 3. So x minus 3, add the right-hand side here, and we get 2. So I end up with x minus 3 squared is equal to 2. So now I'm solving by extraction of roots. Well, I'm isolated here on the left, so I can take the square root of both sides to solve. Squared and squared cancel, so x minus 3 is equal to plus or minus root 2. Is this pretty? Nope, it's not a pretty number, so just solve for x by adding 3 to both sides, and I get that x is equal to 3 plus or minus the square root of 2. So the answer of the solution set here is 3 plus or minus root 2. All right, so we know how to solve quadratics by factoring. We know how to solve quadratics by extraction of roots. Now we can solve quadratics by completing the square. The very last one that we need to do is the quadratic formula. All right, well, how do you solve by the quadratic formula? Well, the very first thing to do is get yourself in standard form. So the only one we didn't need to get in standard form for was extraction of roots. Everything else, step 1, is get in standard form, which is all variables on one side, 0 on the other side. Then you need to identify your A, B, and C term. So you need to figure out which one is A, or A is equal to what, B is equal to what, and C is equal to what. Once you do that, you're going to substitute those values into the quadratic formula. And this is a quadratic formula. And this is something that you need to have memorized. Right? The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, everything over 2a. Again, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? Step 4 is going to be to simplify and reduce. So let's look at these 3 examples. Right, step 1, for example 9, is it in standard form? Let's check. All terms on one side, 0 on the other. Sure am. So that's all done. Step 2, identify your a, b, and c. Well, a is the coefficient of x squared. There's no number in front of x squared, so that's an implied 1. B is the coefficient of your x term. Well, that's a negative 4. And c is your constant term. That's a plus 1, so 1. So I've identified my a, b, and c as 1, negative 4, and 1. Now I just have to substitute it into the quadratic formula. So let's plug in what we know. So x is equal to, well, instead of negative b, I'm going to write negative, well, what's b? B is negative 4, so the negative of negative 4 plus or minus the square root. And instead of b, I'm going to write what b is. Again, that's negative 4, quantity squared, minus 4. Instead of a, I'm going to write what a is, happens to be 1. Instead of c, I'm going to write what c is, happens to be 1. All over 2 times a, and a is equal to 1. So now it's just all about simplifying and reducing here. So let's work through this. The negative of negative 4 is going to be a positive 4, plus or minus the square root. Well, negative 4 squared is 16, and 16 minus 4 times 1 or 16 minus 4, all over 2. All right, well, I'm going to go ahead and erase the quadratic formula that I wrote up here, because again, it's right here, just to move this up and save myself a little space. So next, 16 minus 4 is 12, so I get x is equal to 4 plus or minus the square root of 12 over 2. Well, can I simplify the square root of 12? Yes. Recall that the square root of 12 is really just the square root of 4 times the square root of 3. So it simplifies to 2 root 3. So x is now equal to 4 plus or minus 2 root 3 all over 2. Last thing to do is, can I simplify all these terms on the outside? Well, can I divide 4 and 2 by my 2 down here? I sure can. So in the end, x is equal to, well, 4 over 2 is 2, plus or minus 2 over 2 is 1, so I don't really need to write that, root 3. So x is equal to 2 plus or minus root 3. Again, your solution set, 2 plus or minus root 3. Example 10. Am I in standard form? I sure am. Here's all those variables, and there's 0 over there. Identify a, b, and c is step 2. Well, a is equal to 3, b is the coefficient of your x term, that's 6, and c is equal to, well, do I have a constant term there? I don't, but we can always put in a 0 placeholder for that. So c is equal to 0. Right, let's plug it into the quadratic formula. So I have x is equal to negative b, so negative 6, plus or minus the square root of b squared, so 6 squared, minus 4 times a, which is 3, times c, which is 0, all over 2 times a, which is 2 times 3. Keep working this. X is equal to negative 6 plus or minus the square root. Well, 6 squared is 36, and 4 times 3 times 0 is 0, so really you have minus 0. But do I need to write that? No, because anything minus 0 is just itself. And this is going to be all over 6. 2 times 3 is 6. Okay, keep going. So now I have x is equal to negative 6 plus or minus. Can I take the square root of 36? I can. It's 6, and that's all over 6. And can I reduce this? Yeah, all 3 of these numbers are divisible by 6, so x in the end is going to equal negative 1 plus or minus 1. Can I keep going here? For example, here when x was equal to 2 plus or minus root 3, can I combine 2 and root 3? I can't. But negative 1 and positive 1, those are what we really consider pretty numbers, right? So we have to split this up into 2 equations and solve both. The first one is going to be x is equal to negative 1 plus 1. The second one's going to be x is equal to negative 1 minus 1. So negative 1 plus 1, negative 1 minus 1. And if I work this out, negative 1 plus 1 is 0. Negative 1 minus 1 is negative 2. So those are my 2 answers, and my solution set is 0, negative 2. Last one in this section, solve using the quadratic formula. Step 1, make sure you're in standard form. Am I in standard form? I'm not. I need to get into standard form. Well, how would I do that? I have to distribute this and move all the terms to the left. So let's start by distributing. So 3x times 3x, we got 9x squared. We got minus 9x. minus 15x plus 15, and I'm going to move that 1 over here, so plus 1 equals 0. Well, combine like terms on the left, you get 9x squared. Well, negative 9 minus 15, two negatives, so you add and keep the sign. You got negative 24x, and 15 plus 1 is plus 16 equals 0. Identify your a, b, and c. A is equal to 9, b is equal to negative 24, and c is equal to 16. Plug it into your quadratic formula. X is equal to negative b, so negative of negative 24, plus or minus the square root of b squared, so negative 24 squared, minus 4 times a, which is 9, times c, which is 16, all over 2 times a, which is 2 times 9. All right, let's keep working this problem out. So x is equal to the negative of negative 24 is positive 24 plus or minus the square root. Well, negative 24 squared, let's see, 24 times 24 is 576. So we have 576 minus 4 times 9 times 16. 4 times 9 times 16 would be, that's 576, all over 2 times 9, which is 18. So keep going. X is equal to 24 plus or minus. So the square root of 576 minus 576 is the square root of 0 all over 18. Well, do I really need the square root of 0? No, because the square root of 0 is just 0. So we're really looking at 24 plus or minus 0 all over 18. But again, when we add or subtract 0 from something, it's just itself, so we can really just discard that portion. So we get that x is equal to 24 over 18. Can we reduce that? We can. 24 over 18, both are divisible by 6. So we can say that x is equal to, let's see, 4/3. So your solution set here is going to be 4/3. All right, well, that's it for this section on quadratic equations. Again, we learned to solve by factoring, solve by extraction of roots, solve by completing the square, and solve by the quadratic formula.